This is the web page used to validate the web lab infrastructure developed under my PhD work. This web page is divided in 3 sections. The first one is an introduction. The second one is the validation sequence that you should execute, and the last one will be a questionnaire that you should fill in after doing the validation. Okay. Going back to the introduction, this web page, this introduction basically defines the main topics of the work. You can consult the PhD web page. You can and you should consult before proceeding with the validation the PhD web page, so you can understand the motivations and the idea proposed for the PhD. We have also several papers and a technical document that you can take a look. The important aspect that you should know is the architecture that is implemented in the laboratory. You could take also a look at this presentation that is very important. It is basically a resume of the work. Okay. So you can consult this presentation. Okay, let's go back to the validation page. In the introduction, you can also see the main objectives for this validation is to evaluate the proposed solution, verify if the infrastructure runs correctly, and the idea is to get new suggestions to improve the solution and new ideas for possible user scenarios. Okay, the main idea that I want to get with validation is to see if the methodology is appropriated to create a configurable web lab infrastructure. It will be explored two main aspects. One is the configuration capability of the laboratory, you can see here, and the other is the control. You can also access, for the configuration, you should access a configuration tool interface that is described in this page. Okay, it's a web interface that will be available. For controlling the instruments and modules that will be configured in the web lab infrastructure, you will use an HTTP API provided by the standard. Okay, you have the main components of this API here in this page. What you need to know to proceed with validation. There are 3 main aspects that you should know. The first and the most important one is how do you going to send the comments and get replies from the infrastructure. In this page you can see the main aspects of how do you send those comments. The idea is to facilitate the interaction with infrastructure. So I have provided the comments that will be issued using these buttons. Okay, when you press a button, the comment will be available here in this command window, and replies will be in the reply window. Okay, this is a predefined IEEE 4051 HTTP comments. Okay, and after sending a comment, you can have 2 types of replies: an error reply or a successful reply. The error reply, you can see an error reply here in this page. Okay, you can see here the error code will be different from 0, and if the error code is 0, it means there are no error and the command was issued correctly in the infrastructure. The meaning of the error codes will be available through this connection. You'll see later. You can also monitor the status register on the infrastructure. This is an optional section. If you want, you can use it, but for using this you must know more specificities of the infrastructure, but you can try. This is commands that are available here through this page. And you should, when the infrastructure, you feel that the infrastructure is not working correctly, you can restart the infrastructure by pressing this button. Okay, is a reset command, send the infrastructure, or you can reconfigure the laboratory entirely by using the Rec tool interface. These two options. These two windows, the error reply message and this part to restart the laboratory, you can keep this page open together with this one, okay, if you want to interact with the laboratory. Later you have the validation sequence. The validation sequence includes the use of three main models: a 8-bit input model, okay, the 6-bit output model, and the step motor controller model, okay. And you are going to reconfigure the laboratory or configure the laboratory in two different ways. The first configuration is provided through this image. You will control the laboratory, and you will control three models embedded in the laboratory like this schematic. You have a feedback connection between the output model and the input model here, and you are going to control these two instruments or these two modules using the transistor channel 1 and transistor channel 2. And to control the step motor, you are going to control the step motor control model through the transistor channel number 3. All commands sent to the infrastructure are going to be sent to these transistor channels, okay. The reconfiguration is made through this lab server, okay. In the other configuration that you are going to use is this one. Notice that the experiment under test is the same as the first configuration. The connections to the step motor are the same. The connections between the feedback are the same also, but you are going to change the instruments and models. You are going to change both the positions. You can see the output model is here in the first configuration controlled by the TC2, and in the second configuration the TC2 is controlling the input model. At the same time, in this second configuration there is no step motor control model. The step motor in the second configuration will be controlled by the 6-bit output model that is controlled by the TC1, and the TC3 controls the output model to establish the feedback connection. This is the two main configurations that you are going to use, that you are going to configure the laboratory with these two main configurations, and you are going to validate and test the motor and the feedback connection. Okay, for that purpose you must follow this sequence, okay, illustrated in the table below. You'll start with the configuration 1. You can press this button to see the main aspects of this configuration. It is also important to note that this configuration involves the use of specific TEDs. As you can see in this image, the 8-bit input model only used the DC TEDs, the 6-bit output model the TC TEDs also only, but the step motor used a very important TED besides the TC TED, that is the manufacturer defined TED. Here, this manufacturer defined TED is used to configure and to establish the rules for using this type of step motor controller model, okay. The configuration 1 is like this. In the configuration 2, after doing the configuration 1, after configuring the laboratory in configuration 1, after verifying the configuration and after controlling the models, we will then configure again the laboratory, but now replacing the CM, that is the step motor controller model, with the 6-bit output model, and changing the adaptive PCs to control each instrument and models, as I said. In this configuration 2, you can see that some of the models were changed, and you can see also that the TED used for each model was also changed. You can see that now each of these models use the XDRC name TED that gives a name for each of these models, okay. That's the main differences of this. Later we'll verify this configuration and we'll control those models. And notice a very important aspect. Sometimes some errors can happen, and you should repeat the command more than once. This is caused by the network problems that I didn't solve. Okay. Another aspect that you should take in consideration is that your actions will be logs for future analysis. The idea is to see your actions towards the laboratory. After finishing the validation, you have a questionnaire that you should fill in. Okay. It is very important, I ask you this because it is very important that open questions to be completed as much as you can. It is very important for my PhD, and you could write in Portuguese or in Spanish. It doesn't mind if you have very careful or not in the text. What I need to get is the ideas, the main aspects. Don't worry about the text. Okay, you should fill the first questionnaire is about current web lab problems. The second one is about the implemented infrastructure. It is concerned with validation sequence. It has questions about the configurations, the verify configuration aspect, and the instruments and controls. Okay, you should put in all questionnaires your name and email, so I can know I know who filled in. And the subsection is the relevance of the proposed solution. Okay, and you can see here, and you can submit the answers after pressing this button. Okay, so this is the main web page for the validation. Okay, this web page is also the printable version that I have already sent to you. Okay, thank you.